Okay, so we're going to talk about decimals today, the next place. Dealing with decimals, let's review our whole number place values. Now I'm just going to put them in numerically. We have ones, tens, hundreds, 1,000s, 10,000s, and so on. And what we notice is as we move, every time we move one place to the right, the place value gets divided by 10. From 1,000 to 100, we divide by 10, and so on. So when we get here, if we keep moving to the right past our decimal point, we would keep dividing by 10. Well, 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. 1/1000th. And so on. I always get asked why there isn't a ones place on the right side of the decimal. Well, it's because of that. We're dividing by 10. So there's nothing that 1 over 1 or anything like that you can have. If I have a decimal like 0.34, that is pronounced, of course, 34 hundredths. And that's exactly how we would write it if we were going to turn it into a fraction, 34 hundredths. We look at those and you might be thinking they look suspiciously like fractions. Thank you. And that's because they are. Decimals are nothing more than a shortcut way of writing common fractions that have denominators that are powers of tens. Tens, hundredths, thousandths, and so on. 0.34 is just 34 hundredths. Now, if we were going to convert it into a fraction, we would probably want to simplify that by dividing each of those by 2, which would give us 17/50ths. We might have 0.0375. Well, that's going to be 375 over tenths, hundredths, thousandths, 10,000ths. It's whatever the place value is of that last digit. Another little trick, by the way, there's 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in my denominator. Of course, that can be reduced. Both of those can be divided by, not 3/8. 3/80ths. There you go. Both of those can be divided by 125. So it is 3/80ths. Could have divided by 5 several times, you would get there as well. A little bit trickier is if you have a whole number on it, like 7.835. What am I going to do with that to turn it into a fraction? Well, what do I do with the 7 in front of the decimal point?
Put a 0 in front of it and try that.
Yeah, this is just a mixed number. The 7 is a whole number. It's what after the decimal point that is the fraction part. So 835 over tenths, hundredths, thousandths. Again, 3 decimal places, 3 zeros. And of course, this needs to be reduced by dividing by 5. What's that? 167 over 200. And yes, we got to remember the 7. Put the whole number back in front. So we can convert from decimals into fractions rather easily. We're going to come back to converting fractions back into decimals in a little bit. We all know that like 3/4 is 0.75, and we do that if we didn't know that, if we didn't have it memorized. Remember, we said fractions can be treated as a division problem. You just divide it out. For right now, you have to use your calculator to do that. Hopefully, in a little while, you'll be able to do that dividing out by hand. Addition and subtraction, we talked about this a lot. When we add or subtract, we can only combine things that have the same name. In numbers, that comes right down to the place value. So if I have decimals like 3.84 plus 12.937, what do I have to make sure I do when I set up my addition? Line up the decimal points. Why do I line up the decimal points? Well, because when I add or subtract, I can only combine things that have the same name. So the 8/10ths and the 9/10ths, 4 hundredths and 3 hundredths, 3 ones and 2 ones. I have to line up the place values because those are the only things I combine, the things that have the same place value, the same name. Now I'd fill in a 0 here just to fill up the thousandths in the first number. And then I'm going to go ahead and add. So I got 7, 17, so that's a 7, carry the 1, 4, 6, and 1. So the decimal point comes straight down because when we add or subtract, we keep the same name. Now for subtraction, I'm not going to do a lot of examples either, but I'm just going to do one big one like this. When I go to set this up, where's the decimal point in the 8? Yes. If there's no decimal point in the number, it's at the end of the number. So when we line that up with the 2.3974, fill in the zeros, and then we're going to subtract. Well, we can't do 0 minus 4. We need to borrow. But there's nothing here to borrow from. So what do? We keep going until we run into something. We can borrow from the 8. It's now a 7. This is a 10. But we didn't need it here. We need it down here. Borrow from the 10. This is a 9. Now this is a 10. And we keep borrowing. So now, 10 minus 4 is 6. 9 minus 7 is 2. 9 minus 9 is 0. 9 minus 3 is 6. The 1s come straight down because we keep the same name, keeping the tenths as tenths and the 1s as 1s. 7 minus 2 is 5. So yeah. I realize I'm blowing through the decimals really quickly. But you can do the decimals on your calculator is really easy, so I'm not going to spend a lot of time on it. So anyway, multiplication. Let's do 3.84 times 2.5. When we set up multiplication, do we have to line up the decimal points? No, we don't. Because when we multiply, we don't need the same name. In fact, we're going to ignore that the decimal points are even there. We're going to do 5 times 4 is 20, so 0, carry the 2. 5 times 8, 40, plus 2 is 42, so 2 carry the 4. 5 times 3, 15, plus 4 is 19, so 9 carry the 1. Now I'm going to do two things. When I move over to the 2, I still have to add a 0 here. Now I'm going to put a line up here so that when I know that whatever I carry is going to be up above that. So now 2 times 4 is 8. 2 times 8 is 16. There's nothing above the line carried, so I know I'm good. So 6, carry the 1. 2 times 3 is 6, plus 1 is 7. And we add our columns. We got 0, 0, 16, and 9. Where does our decimal point go? Between the 9 and the 6. Why there? Yeah, so you've got 1, 2, 3 decimal places in the problem. 1, 2, 3 decimal places in your answer. You got to be very careful, though, because these zeros can screw you up. Some people will drop those zeros and forget about them. You have to keep them in there until you locate the decimal point. Another way to look at it is this is about 4. This is about 2 or 3. 4 times 2 is 8. You're expecting an answer. If it was 4 times 2, it would be 8. 4 times 3 is 12. You're expecting an answer between 8 and 12. So 9.6 is the only one that makes sense. 96 doesn't make sense. 0.96 doesn't make sense. So that's a 2. That would be a 3. There, is that better? Okay. Division of decimals. Now I'm just going to put this out there quickly because long division with decimals, I don't even do it by hand unless I'm forced to. I use the calculator for that as much as possible. So if we have something like 2.3 going into 48.74. We don't like to divide by decimals. We can do it, but it goes back to an old process that hasn't been taught for probably 120 years. So what we do is we avoid dividing by decimals. And how do we avoid it? You move the decimal. Very good. Think of it like this. That division can be turned into a fraction, like that. And on a fraction, we can multiply the top and bottom by the same thing. If I want to get rid of the decimal here, I multiply by 10 to get 23. So I multiply the top by 10 to get 487.4. If there were 2 decimal places here, I would have multiplied by 100 and so on. So that means I move this decimal point over 1. This one has to move over 1. And the reason for that is because what we were just doing here, we're treating it as a fraction, multiplying the top and bottom by the same thing. So this becomes 23 into 487.4. So now, just like any other long division, and let's say I want this to the nearest thousandth. $23 goes into 48. Twice. 2 times 23 is 46. These are 2. We bring down the 7. 23 into 27. Energetic crowd today. Once. 1 times 23 is 23. We're left with 4. What do I have to do before I can bring down that next 4? I put the decimal point up. I cross the decimal point, I've got to do something with it. That's why we're so careful to keep these digits above the last digit we use so we know where that decimal point has to go. Now we can bring down the 4. 23 into 44 is still only once. We're left with 21. Now what? Are we done? We're out of digits. We can actually add as many zeros as we want to, can't we? So we'll keep going, bring down a 0. 23 into 210. Let's try 9. That'd be 7, carry the 2, 18, 20. So we're left with 3. We can bring down the next 0. 23 into 30 is once. Goes in there once. There's 23 to 7 left over. We're to the nearest thousand. We're to the thousands place now. Are we done? Do we stop now? No, we have to go one more 0. We bring down that 0. 23 into 70 goes 3 times. The reason we had to go that one more place is because now this tells us that this really is going to be 21.191. If that 3 was 5 or larger, it would have been 0.192. We would have had to round it up. Any questions? Okay. So on page 63 through 65, there's 1 through 73, the odd. And then on page 72 through 75, 1 through 67, the